So I didn't really have enough time to complete that lesson on the 15 minutes, so I'm starting off over here. So you watch the first lesson and then come back to this one if you've clicked this one by accident. But just remember that these ions are all trying, or these atoms, these neutral atoms, are all trying to look like noble gases. Okay, and sometimes if you're looking at the periodic table, let's go up to the periodic table. It's easier to gain electrons, such as group 17, group 16, and group 15, where other times it's easier to lose electrons, such as group 1, group 2, group 13. Okay, so it depends on how many you have to gain in order to get the normal gas state, or how many you have to lose to get to the normal gas state. Like I mentioned earlier, it's easier for lithium, sodium, potassium to lose one electron as opposed to gaining 7 electrons to become an ion and become stable and look like the noble gases. Okay, and groups 17 and 16, it's easier for fluorine, chlorine, and bromine to gain electrons, to gain 1 electron, as opposed to losing 7 electrons. Again, always to look like they're noble gases. Okay, fluorine wants to look like neon, chlorine wants to look like argon. Okay, so they all want to look like those noble gases because the noble gases are just good looking atoms. They're nice and stable. They're not very reactive. Okay, and so that's what these atoms, these neutral atoms, are trying to look like. They're trying to gain a full outer shell, just like the noble gases. Okay. Um, so we talked about cations and anions, and when you have a cation and an anion, okay, to form a bond, okay, an ionic bond, okay, anions are given the ending in IDE. You do not put cations given the ending in IED, okay. The negatively charged anion, is always given the ending of IDE. Okay, so for example, sulfur atom, okay, it loses the 2 electrons, becomes sulfur -2, and then it becomes a sulfide ion. Okay, oxygen, if we look up here, loses how many here? Okay, so it loses, it's above sulfur, so it's group 16. To get to group 18, it needs to lose needs to gain 2 electrons. So what happens is it becomes negatively charged, oxygen -2, and it becomes oxide ion, oxygen atom, unstable, oxide, looks like a noble gas, nice and stable. Okay, so for anions, you're always giving the ending IDE. For cations, you do not give it any ending. It's still calcium, it's still sodium, it's still aluminum. Okay, since valence electrons are the only electrons involved in bonding, it is way more convenient for us, instead of drawing Bohr-Rutherford diagrams, it's much more easy to draw electron dot diagrams. Okay, as the electron dot diagram only tells us the amount of electrons within the outer shell of that neutral atom. Okay, so if we look at sodium, we know that sodium only has 1 electron in the outer shell, and there's that 1 electron. You look at fluorine, we knew that fluorine had 7 electrons in its outer shell, so 1, 2, 1, 2, 3, 4, 5, 6, 7. Okay, and it's much easier to view it that way as opposed to viewing it with the whole Bohr-Rutherford diagram, and you have to draw all the inner shells, things like that. Okay, so this way it's easy to say, okay, well, they only need to lose 1 electron, or here you say, oh, okay, it only needs to gain 1 electron. You know what I mean? So it's a little bit easier to see that see the outer shell this way as opposed to the Bohr-Rutherford diagram. Okay, and that is the end of the lesson for cations and anions. If you have any questions, just let me know.